everybody. I hope you guys are having a wonderful day today. In this video, we're going to talk about the 11 different types of addition and subtraction word problems that can show up when you're applying addition and subtraction to real-world situations. So these 11 different types of word problems can be categorized into these 4 categories. So we have join word problems, separate word problems, part whole word problems, and comparing word problems. So let's start off with the join word problems. So the general structure of a join word problem is you start with a certain amount and then you increase that amount in some way. So it could be like you start with, let's say, like 5 pies and then you make 7 more pies. That would be a positive change because you're making more pies and you would end up with your total or your result. But this change could also happen by someone giving you more pies, but basically you're increasing the initial amount that you started with by some number. And when you're writing a word problem, or when you're helping your students interpret a word problem, any one of these 3 parts could be missing. So you could have the start unknown. So in this word problem, it says Maggie has some candy. Susie gave her 4 more pieces of candy, and now Maggie has 9 pieces of candy. So this is a join problem because you're starting with some initial amount, and then Susie gave her 4 more pieces of candy, which is increasing it, or a positive change, and now she has 9 pieces of candy. And so if we wanted to help our students write a math sentence for this, we would say, okay, well, how much did Maggie start with? Well, that's the thing we don't know. That's the question we're asking. And so I could write a question mark for my starting amount. Then I could say, well, after Susie gave her 4 more pieces of candy, then that means that I'm increasing the amount by 4. And this equals the result of 9 total at the end. And once you have the math sentence written, then you can help your students identify what they need to do to be able to find out what the question mark is. So some of them might use their memorized math facts to let them know that the question mark is going to equal 5. Some of them may use subtraction and do 9 minus 4 to equal 5. But writing out a math sentence that communicates the idea in the word problem is a really helpful strategy for solving word problems. So this is an example of a join problem where the start value is unknown, but you can also have a word problem where the change value is unknown. So this is basically the same word problem, but we're missing a different piece of information. So in this one, it says Maggie has 5 pieces of candy. Susie gave her some more candy, and now Maggie has 9 pieces of candy. And so again, this is still a join problem because we're starting with the 5 pieces of candy, but now we don't know how much is changing. We just know that Susie gave her some more candy, but we don't know the amount. So that's where our question mark is. And then the result, or the ending amount that Maggie has in total, is 9. And so again, writing out this math sentence will help students be able to solve it because at this point they can either use their memorized math facts or subtraction to find the question mark. But notice that this is a different type of word problem than the one that we had before because the piece of information you're looking for is different. And so when students are learning how to solve addition and subtraction word problems, these 2 problems feel very different to them because the thing that you're looking for is different even though the structure of the overall situation is the same. So you can either have the start unknown, or you can have the change unknown, or you can also have the result unknown. So in this example, this phrasing of the word problem says Maggie has 5 pieces of candy. Susie gave her 4 more pieces. And the question is how many pieces of candy does Maggie have now? So in this one, we would have 5 with an increase of 4. And the thing we're looking for is the result. And in this math sentence, the math sentence is set up where you can just simplify this to find out what the result is. And so that would be an example of a join problem where the result is unknown. The next category of word problems that we're looking at are separate word problems. So in a separate word problems, you start with a certain amount and then you have a negative change. So in join problems, you're increasing your starting amount, and in a separate problem, you're decreasing it. So this can either happen by giving away a certain amount of things. So like if you had, I don't know, like 12 pies, you could give away 7 pies. Or it can also happen like maybe you ate the pies or something that made the initial amount decrease or separate from itself. And then you end up with your final result. So just like with the join problems, you can have different parts of the problem be missing. So if you have your start value unknown, an example of what this could look like is this example where Doug has some marbles. He gave 5 to Joe, and now he has 8 left. Well, the sum marbles that we don't know the amount is the starting amount. So that would be our question. And then if he gives 5 to Joe, that's the negative change or the takeaway amount. And then he has 8 left, which is the result. And so this would be the math sentence that represents this word problem. And then once you have the math sentence written, then you can help your students figure out strategies for finding the missing value. So one of the strategies that can be really helpful when the math sentence has a question mark with other information on one side of the equation is to use the idea of fact families. So fact families are the groups of math facts that are all related to each other, either by commutativity, where like if you switch the 2 and the 3, you get 3 plus 2, or by inverse operations. So addition and subtraction are inverse operations because they undo each other. And so the addition fact 2 plus 3 equals 5 can be rewritten as 5 minus 3 equals 2. Or you can also write it as 5 minus 2 equals 3. And so fact families can be a helpful way for helping students figure out missing values in math sentences. Because if we went back to this problem and we have this math sentence that question mark minus 5 equals 8, well, if you rewrote this using one of the facts from our fact family, you could rewrite this as 8 plus 5 equals question mark. And that would make it a little bit easier to solve this problem. And some students may come up with their own strategies for solving it, and that's totally fine. You don't have to use the fact families. But being able to take the word problem and write it as a math sentence is a very important skill for students to learn. So with the separate type of word problems, you can also have the change unknown. So let's say that we have the word problem that says Doug has 13 marbles, and then he gave some of the marbles to Joe, but we don't know how much, and we know that Doug now has 8 marbles. Well, we can write this as a math statement by saying, well, if I have 13 to start with, and then he gave away some amount, which I don't know, so I'll write it as a question mark, and the amount that Doug ends up with after he gives some of his marbles to Joe is 8. This would be the math statement that communicates the information given in this word problem. And again, once you have the math statement figured out, then you can help students figure out what that question mark value is. So in this case, I would probably use fact families again, but again, some of your students might come up with other ideas. And as long as their reasoning is sound, it's totally fine for them to use their own strategies there. Okay, so the last type of word problem in the separate category is the one where the result is unknown. So an example of this word problem would be Doug has 13 marbles. He gave 5 to Joe. And how many marbles does Doug have left? So in this case, we know the starting amount. We know that that's 13. We know that the change is that he's giving away 5. And the thing we're looking for is the result. And so that's the third type of separate problem. The next category of word problem is the ones where we have part, and whole. So the structure of these word problems are going to be where you have 2 parts, and together those 2 parts make a whole. So an example of a word problem where the whole is unknown is you could say that Kate has 3 dogs and 5 cats, and you're trying to figure out how many animals she has. So this is a part-whole problem because the group of animals is split up into 2 parts. You have the dogs and you have the cats. And so the math sentence for this would be 3 plus 5 equals the thing we're looking for, which is the number of animals she has. And so notice that this is a different structure than a join problem, because a join problem would be like you have 3 dogs and then you have 5 more dogs come and join the 3 dogs. Versus in this case, you have both parts at the same time, like one isn't joining the other group, but the structure of the math sentence is still the same. You're still adding the 2 pieces together, but conceptually for your students, these are 2 very different ideas. So you can have the whole unknown, like in this case, or you can also have it where the part is unknown. So for example, it says Kate has 8 animals. 5 of the animals are cats and the rest are dogs. How many dogs does Kate have? Well, in this case, the 8 animals is the whole, so that would be where the 8 goes. And then we know that 5 of the animals are cats and the rest are dogs, and we're trying to figure out how many dogs there are. So we could say, well, 5 plus the number of dogs is going to equal the total number of animals. And so this is how you would write a math statement when the part is unknown. And then you could use math facts or fact families or whatever strategy you want to find the missing value. So that's the part-whole type of word problems. And then the last type of word problem is a compare word problem. So in a compare problem, you're going to be given 2 different values, and you're going to be comparing those 2 values. So for example, you could say maybe like Mary is 5 feet tall and Bob is 4 feet tall. In this case, the difference would be 1 foot, because Mary's value minus Bob's value equals 1. And that means that Mary is 1 foot taller than Bob is. And this can be visualized really well with counting blocks. So if you put like 5 little counting blocks on top of each other, you know, those ones where you can like stick them together. And then if you have 4 of those counting blocks, or you could also do this like on a number line as well. But this makes it easier for students to visualize that Mary is 1 foot taller than Bob, because there's kind of an empty space of 1 foot above Bob's height compared to Mary's height. So this is the idea for compare word problems. And just like all of our other word problems we've looked at so far, you can either have the big value or the small value, or the difference be missing from the problem. So an example where the big value is unknown is this one, where it says Ellie has 4 apples and Jacob has 3 more apples than Ellie does. How many apples does Jacob have? So if I were teaching this to my student, I would say, okay, so if Ellie has 4 and Jacob has 3 more apples than Ellie does, who has the bigger amount of apples? And they would say, well, Jacob has the bigger amount of apples because he has 3 more than Ellie does. But we don't know how many apples Jacob has, so that's where our question mark is going to go. And then I'd say, okay, well, who has the smaller amount of apples? Well, that's Ellie, and Ellie has 4 apples. So I can subtract Ellie's amount, and that's going to give me the difference between the amount that Ellie has versus the amount that Jacob has. And they told me that Jacob has 3 more apples than Ellie does, and so that would equal 3. So you could teach this problem in this way, where you say like Jacob's amount minus Ellie's amount is going to equal the difference. Or you can also rewrite this to a similar math fact that's in the fact family. And you could say, well, if you take Ellie's amount and you add 3 to it, then that's going to equal Jacob's amount. And this math fact communicates the same information, and so students could solve it in either way. Basically, it's whichever way makes the most sense to them. And then you can also have word problems where the small value is unknown. So we could say Jacob has 7 apples and he has 3 more apples than Ellie does. How many apples does Ellie have? Well, we could say, okay, well, if we take Jacob's value, he has 7 apples. We don't know how much Ellie has, but hers is the small value. And so we'll do a question mark for that. And we know that Jacob has 3 more apples than Ellie does. So if you take away Ellie's amount, that gives you a difference of 3. And you could rewrite this math fact to a similar math fact from the same fact family. And you could say that Jacob's amount minus 3 would equal Ellie's amount. And that strategy may make more sense to your students, depending on the way they like to think about it. Because if you have 7 apples and then you take away 3 of them, well, 7 is going to be 3 more than whatever that answer is that you end up with. So that would be an example of a compare problem where the small value is unknown. And then the last type of problem is one where the difference is unknown. And actually, this is a typo. This should say difference. And so in a compare problem where the difference is unknown, we could have an example where Jacob has 7 apples and Ellie has 4 apples. And we want to know how many more apples does Jacob have than Ellie. And so in this case, Jacob's value is the large value that we're comparing. Ellie's value is the small value that we're comparing. And the difference between them is what we're looking for. And so that's how you would do a comparing problem where the difference is unknown. So to summarize, we have 11 different types of word problems, and they're split into 4 categories. So the 11 types of word problems are based on which part is missing in these categories. So you can have the start missing in a join problem, or the change missing in a join problem, or the result missing. Or you can have a separate problem where the start is missing, or one where the change is missing, or the result. In a part-whole problem, you can either have one of the parts missing, or you can have the whole missing. And in a comparing problem, you can either have the bigger value, the smaller value, or the comparison between the two missing. And so that makes up the 11 different types of addition and subtraction word problems. So if you guys have any questions, let me know, and I hope you guys have a great day.